So let's quickly discuss what we'll be talking about today, which is the assembler and service broker solution, which is in the Aria automation suite, which is part of a larger suite of what VMware offers. But these are all solutions that I have here on the screen that are designed to tackle DevOps in some capacity, designed to help you manage a data center, designed to help you with automating your data center. And that's specifically where we're going to be focusing today. And for those who were with us on the previous uh, uh, cloud conversation 3 months back, we covered config right down here, configuration management, which is for day two, patching, updating applications, maybe redeploying an application, but it's basically a tool for deploying CLI commands in bulk across many VMs throughout your entire data center. So today we're going to be talking about Assembler Service Broker, which is more of a day zero type of operation, and we'll talk more to that. Your presenters are myself, Wesley Mora, Southeast, Aria's Cloud Solution Architect, and Alonso, you can introduce yourself.
Yep, good to meet everybody. So I work with Wesley in the cloud management space as another solution architect on the team. Look forward to the discussion.
And one of the things we talked about in the last cloud conversation was that infrastructure is complex. And specifically, let's go over why. Typically, you are dealing not with just one VM, but multiple VMs, one running a load balancer, a few running a web server, maybe a few running a database application. And you have this distributed architecture, in tier, 3-tier, 5-tier, whatever you want to call it. But there's a lot of different VMs that have to sort of be paid attention to. You have to measure metrics on them. You have to make sure that they're updated. You have to make sure that if you want to test these types of infrastructures, you need to sort of automate the process of spinning up, creating all these VMs, networking them. And again, it gets further complex with a real blueprint because in reality, you're going to have, in addition to storage solutions, you're going to have Redis or cache instances and all different types of infrastructure that has to be spun up and connected in order to properly test it. So uh, in a nutshell, what you're trying to do is take many layers of infrastructure and figure out a way to zoom in on them, to zoom out and to zoom in on them, to abstract away detail when necessary and to uncover the detail when necessary. This is just a quick overview of how Aria operations for monitoring also plugs into this because our operations for monitoring workflow will also give you insight into what Assembler is doing. But again, today, we're mostly talking about Assembler. And again, Assembler plugs in. This is the same DevOps lifecycle that we discussed on previous webinars, but I'm going to overlay 1 through 8, the plan, code, build, test, release, deploy, operate, monitor sequence. But it's an infinite life cycle, and I'm going to overlay some of our products, see where they kind of fit in. What we're going to find today is that Assembler fits into stage 6, but it also fits into around stage 3 with the service broker side. And we'll discuss the differences of what service broker and Assembler are. Further, just to give everybody some familiarity with some of the other solutions that are available in this marketplace. VMware is not a monopoly. If you're familiar with some of these names, it might give you some clue as to where some of our solutions are competing. And the ecosystem gets even more diverse than that. Those are just some of the solutions. I'm going to do a quick introduction on the DevOps lifecycle referencing a restaurant chain, because I know that I want to take some of these abstract nebulous concepts and make them a little bit more concrete. In short, the DevOps lifecycle is not an IT management specific domain lifecycle. You could apply it to a restaurant, you could apply it to any manufacturing company or any project that has processes. So moving from left to right, top left to bottom right, you can see here I've numbered the lifecycle stages the same, the plan all the way down to the operating monitor in number 7. But a restaurant, a franchise restaurant, has the same process whereby they have to figure out where the problem lies. Maybe they don't have enough items on the menu. Maybe their competitors have more. 2, they have to design some new menu items. 2A, maybe design a recipe around that for that specific menu item. They have to have a version controlling process because not every idea right out of the gate is going to become perfect. So you're going to have maybe 2, 3, 5 different types of recipes, and you'll need to test them. So that process of building and testing, which here on the slide that we're looking at, 3A, 3B, and 4, that's kind of a little bit of an infinite loop inside of the broader loop of 1 through 7. And that's the important thing to understand here, is that the process of building and testing going around and around is time consuming. And it's the most important part of the process, because after that, in step 5, when you release this menu item and it starts to be produced across all your different restaurants and your different fast food chains, the problem you're going to have is that your customers are then in the line of fire and they have become your lab rats. And you'd rather have your lab rats be closer to the 3-4 testing range. And what a restaurant might do is they might hire a firm to bring in professional food testers or tasters, or they might have they might just go on the street and do random food sampling. But the point is, it's going to be a testing closed environment. And that's what Assembler and what Service Broker is going to be providing for you, is that closed testing environment. Our pipeline is our tool that actually does the testing, but that'll be in a future cloud conversation. Today, it's just the automation of building up your infrastructure. And real quick, just so that you can sort of see what it looks like for the IT lifecycle, this is just as I was showing for the restaurant lifecycle. The build automation, I'm going to actually put words in here instead of the pictures. So looking at 3A, we're going to be developing self-service role-based access control tools. We'll kind of highlight where those are. That's in the Service Broker side. Approval workflows, which are configured on the assembler side, and other workflows such as the ability to audit events, find out what's been deployed, what's not been deployed, find out costing information, all of these other aspects that need to be sort of addressed with the IT workflow. But having said that, I'm actually going to, Alonso, I'm going to jump down to your slides here, because I don't think we need to actually cover Aria config too much in detail here. And I'll let you talk to this slide.
Sure thing. And just as a transition, in a way, a recap of what we were discussing with Aria config, right? And some of the components that are more on the operating system management and software management side of the house, those are part of a larger stack, right? As we know of the data center administration process. On top of the operating system are the packages, the users, services, tooling, middleware that might be required to run a given service. And that's where we start with Aria config. Now, on the next slide, actually, what we start seeing is how we can expand this management of Aria config and the value add that it provides to be on multiple different kinds of operating systems, regardless of where they live. And that's a key phrase that we'll get into in a moment. But ultimately, you will have virtual machines or workloads containers, right, clusters and so on, with specific identities, some kind of database service, or some kind of web service, or some kind of internal employee tooling service, dev tools, and so on, in addition to your traditional file servers and so on. They're all going to have some kind of identity. The service is what gives them the identity. And in that process, you're going to want to lifecycle the service, give it an identity, harden the operating system for security purposes, things of that nature. All of that is still within the realm of what we call configuration management, right? And Aria config as a way to approach this, which we discussed on the last call. On the next page, please. Now we talk about where that lives. So the operating systems and the services living inside that OS, those have to live on infrastructure, right? And almost across the board nowadays in the industry, we have virtualization as a methodology in order to have these services live on resources in a highly available, but also resource effective way. And so one of the methods is, of course, with vSphere and hypervisor technology, right, running virtual machines. Another form of what I would still call virtualization is containerization, right? And the ways that you can essentially take a shared pool of infrastructure and have multiple services use it. Underneath that, depending on who you're using, right? Maybe you're a public cloud user or a colo user. There are going to be different levels of the infrastructure stack itself that either you have to maintain or own or somebody else does. But really our focus today is taking this idea of what is a service at the operating system level, at the software level, application level on top of that, and saying, where am I going to put this? Ultimately, where is it going to go? And what are some of the specs around making that deployment happen? So on the next page, one of the things that we try to maintain during this process of, well, your operating system and application or software could live on as many OSs as we can try to support, right, with the SALT infrastructure. And taking that a step further and saying, in addition to that, we want to be able to support multiple platform options. So there's the VMware options, right? The vSphere options on a private data center. There's the vSphere options on the hyperscaler. So VMC, there's Azure VMware Solutions, there's Google Cloud VMware Engine, and so on. So VMware in these clouds. But then there's also the native cloud platforms, right, with their hypervisors. And being able to deploy into these different environments from one platform, from a central location. And that's a big focus of the assembly or automation platform from a virtual infrastructure perspective. Next slide, please. Now, when it comes to the deployment itself, there's usually going to be two sides to that process. There's going to be those that configure what does a deployment look like? Where can it go? What are the approved images, approved sizes, and so on? What are the policies, say leases and approvals? And then there's going to be the requesters, the one who actually need that infrastructure, that service, that operating system for something. It could be the same team. Usually it's different. Usually you'll have a developer, you'll have some kind of engineering resource that requires virtual machines or maybe adjustments to an existing virtual machine, some kind of day two action. And then you'll have the ones that actually do the work, right, of configuring what does that look like. With this balance rose this idea of how do we do this at scale? And the answer to that across the industry has been the answer is a way to self-serve, a way to make the ones who need those who are making the requests to give them a standardized way of making those requests to IT, or even making those requests happen themselves without IT getting involved, because that's already been vetted. It's been blessed and configured on the front end already. Next, please. And so this gets to the idea of when we're making a request for a given virtual machine, or we're making a request for a given service, the deployment of infrastructure, the change to infrastructure, making it so that the right people have access, the right kind of access to requests. So a certain project group has access to certain infrastructure. A certain user or group of users have the ability to do certain tasks on their infrastructure. That kind of access control, permissions control, is another key point of making all of this possible at scale. And so through that, we get into some of the big benefits of, and also capabilities, right, of the self-service framework, where it's not that IT is handing over control to somebody else. It's they're like a release valve, deciding how much and who gets access to parts of the environment and what can they do during that request process. Wesley, next page, please.
Yep. And so I think we're going to transition to bringing up the platform here, but I want to underscore the process that you were just talking to with that service broker, because we're going to start here on the service broker side. The service broker side is the consumption side. This is where your developers, this is where anybody who's deploying infrastructure is going to come to, and they're going to have a menu. And going back to the restaurant example, this is what they can and what they cannot deploy. It's permissioned. So some people are going to have access to deploy 30 virtual machines. Some will have access to deploy one virtual machine. And this is all in an effort to not just control costs, but also control and efficiency, how the resources are being utilized, so that you don't have sprawl going on and your hosts are being misused. And then you find yourself having to buy a new host just because the current hosts are currently not being used effectively. So that's where we find ourselves now. This is the service broker interface. Did you want to take control of the mouse here, Alonso?
Yeah, I can go ahead and click, see if it lets us here. Okay. Excellent. All righty. And so as Wesley mentioned, this would be what an example experience could be for an end user. This is the native built-in service catalog that our platform here, our automation platform, has. It doesn't have to be the way that your end users request infrastructure. We have open API, so that API system could be configured for your own custom forms, right? If you need it to be super customized. We also have integrations with a very popular one is ServiceNow. So that requests come through ServiceNow from the end users to this platform for actual servicing. Different ways to approach it. We'll go ahead and actually use this native catalog for this particular example for a discussion today. And an example as an end user, I, as Alonso, am part of multiple projects, right? And what projects really mean is I'm part of multiple user groups that have access to different things. In this case, one of them is MOAD. And so I show the MOAD project, though there are several others right? Different projects that have access to different kinds of templates. And what ends up happening here, if we go back to Moad for a moment, is I can, as an end user, make a request. And in this case, I make a request, and the IT teams, the operations teams on the back end specify, well, what do I need from you in order to give you this infrastructure or to make this request happen? And as part of that, we can see that, for instance, you can specify, well, I need a deployment name. Okay, so we'll go here and do something like ATM new server. And this might not be super descriptive. We'll get a little more into why. Well, we also have the ability to add things such as, what is the target environment? This could be a black box that I never touch, or it could be something that they give me right here in the self-service request form. And ultimately here I can decide, well, where do I want to place this? It could be AWS or Azure, it could be vSphere. It just depends on how the back is configured for me to access it and for this deployment to work. Then we could actually even go a step further. And this ties into what we were talking about before with there's the virtual infrastructure and the request of, say, a server or a VM. And then there's the request of, well, that server is going to have an OS. It's going to have services. It's going to have a purpose. And so we can tie the idea of, say, Salt Stack, or we also work with Ansible and the Puppet, and tie those into the deployment of that server so that the end user tells us, I want this. Okay, well, then let's trigger the workflows for that to be possible, for that to be delivered. So I could do things such as request an Apache machine, right? And the OS type, well, it's going to be Linux in that case. And we'll provide some information. This could be obfuscated if we wanted to. In this field, we did, and we made a plain text, but you could make it obfuscated. Here's an important one: tagging. Across many of the customers that we end up talking to, a solid tagging enforcement strategy is not it's not common. And one of the things that this can help with is say, well, as part of this request process, sure, you can have this, but we're going to need you to tell us owner or who is the call center that this is tied to. Maybe for reporting purposes, we would have to give it automatic tags or requested tags like we're seeing here of this infrastructure is going to be tagged in this way. It's part of this group. It's part of this environment. And so that can help you with your inventory, your reporting, in addition to your general tagging strategy.
And those tags, of course,
yep,
those tags can be. So with Aria operations, just to take it back to that, because I touched on it very briefly towards the beginning. When Aria operations starts to look at your Aria assembler environment, it can look at those tags and start to sum up the cost by the tagging system. So the tags can travel outside of assembler downstream to another application to be utilized there, or you could use the taggings as we'll see here. It's pretty common to have to rely on tags inside of the assembler platform itself.
Mm-hmm. Yeah, that's a good call out. And so tagging can also, as I mentioned, so you can use tagging as part of your reporting methods and essentially get a way to, when the request is made, you already have the metadata that you need to organize that information. And so we actually see ties into operations from a reporting standpoint in that sense. So maybe the tagging will then associate it with the right group, maybe the right report later on. We can also see things such as operations actually giving us some details. So we actually, for a VMware environment, we can actually get price estimates from operations to say, well, based on the infrastructure that you're deploying to, then this is what the pricing that is built into ops is telling us it's going to be. So here, the cost of servers, the cost of storage, the cost of network licensing leads us to get what this pricing is going to be like. That can be
that's very helpful. That's particularly helpful when you're using native public cloud like AWS or Azure or GCP, because people don't quite realize how much the infrastructure costs. But like a simple Kubernetes cluster can be $6, $10, $15 per day. So the more people understand what it's costing, they won't be they won't be leaving the lights on as much. So again, this is the consumer side. Obviously, the admin can see these costs as well, but this is also visible to the consumer.
Yep, great point. And as a note on that, on the native public cloud, that the way that we would do that is we would tie into, say, your billing, right, through a sister platform that we have, and that could pull in the information of what exists in the environment and how much it's been costing you through billing. It's in the works to get a price estimate for the native public cloud. It's not currently available today for native public clouds, but that's something that is being considered as an option. For now, it's for VMware, as at least estimates are for the VMware vSphere deployments. Right, so we go ahead and make that request, and it's going to start kicking off quite a couple different tasks here. And if we go into that actual deployment itself, we can see my server actively being created. So that virtual machine, and then the salt components, in this case, we're using salt to start giving it that identity. So an identity of the kind of, not just the OS that's attached to it, because the OS you define your image, right? But in that OS, what are some of the, say, users that need to get created, packages that need to get installed, and permissions that need to get set, then maybe starting of services within that operating system. That kind of activity that you would do post deployment of a VM is what we can start adding on to our existing deployment.
And just to make it clear what's actually occurring here. So assembler is an orchestrator, and it is talking to your vCenter. Your vCenter, of course, is talking to your ESXi hosts and telling it to deploy these VMs. Further, on top of deploying the VM, it's also deploying an application salt stack config, also known as Aria config, just in case anyone's not following the two different terminologies we're using. But salt stack config is the same thing as Aria config. So it's installing the application and configuring the application, which we can see in the config files here, and setting all that up automatically. So this is a blueprint that's being deployed automatically. And this is a simple blueprint with two VMs. Imagine at the top of the talk where I kind of share that blueprint with 50 different services running. It would take you all day to deploy 50 different services because you can't deploy them in unison. You have to deploy A and B, then wait for B to finish before you can deploy C, and then wait for C to finish before you can deploy D through M, and so on and so forth. It takes forever. The process needs to be automated. Assembler is orchestrating this and just telling vCenter what to do, which is in turn telling your ESXi host what to do.
Mm-hmm. Yep. And so as part of that, we see also some of that organizational component as well, metadata component to it, where we have a tag application MOAD that was added actually automatically. So that wasn't something the user was requested to give. It was something that just based on the deployment, it tagged that infrastructure a certain way. Same with the project. And then this is the one that the user was prompted. So we've actually set or toggled to cost center operations, because that's what I provided when I made that request as an end user.
And so, Alonso, we need to actually get out of the service broker view into the assembler view to see that YAML code. I saw you looking for it.
Absolutely. So yeah, so that's something that we will get to. So if we want to look at, say, the example of what we were talking about here, and not to get too deep into the weeds, because this is the design canvas. It has some code on the right? It has a visual on the left. And then it looks like a list of items that we can drag and drop here as we need to. The big thing to take away from this design canvas section is the fact that you have two different ways of looking at something. One of the ways helps you understand relationships extremely well. What is connected to what? And that is extremely helpful, because then you can go ahead and create your code based on, or create your deployment scheme, your schema right here, using a visual. And so then you have this visual on the right side, which is extremely important for version control, for export and import, for things such as making more detailed, granular adjustments to your objects. That needs to be done in code. But then you have a visual on the left side that says, if I need a quick spot check on what's going on, I can see immediately it's a network, a virtual machine, and a salt stack resource. I want to now, in say, a native public cloud setting, I want to start experimenting with buckets, right? S3 buckets, or I want to start experimenting with Route 53, or let's ideate on this existing application. What if we were to use something else like a Lambda function or an Azure function? Here's where you can start actually creating and changing the design of your services and testing, seeing, does it actually make sense, or was it just a thought, right? And so here's where you have a design canvas or design studio where you can, over time, getting started with a virtual machine and a network, right? And then going from there, you can start creating deployments that not only get more and more true to the design attempts and cycles that you want, but you also have an encoded way of repeatedly deploying it, so that you don't have to have the human error aspect is reduced drastically, because the steps are encoded into your process. And from an end user perspective, they don't have to deal with this complexity. They just have that request catalog that we saw before, that request process. And on the back end, you've defined, what does that actually look like? What is the OS that gets used based on what they pick? What are the usernames and passwords that are going to be used? Or things such as, what is the way that we're going to get a network? right, connected to this virtual machine, static IP, dynamic, and so on.
Yeah. And keep in mind that, let's take it back to the restaurant example. So again, if we're in stage 3 and 4 and you're developing a recipe, you have your cooks in the commercial kitchen and they're, putting together many different iterations of the recipe to see which one tastes the best. That is essentially the YAML code, whether you're adding 1 tablespoon of salt, 2 tablespoons of salt, 3 tablespoons of salt, and all the version controls that have to happen. If you would, Alonso, can you click on version history there in that top left?
Sure thing.
So we keep track of all the different versions because you just never know. You might get 6 versions down the road and realize, oh my gosh, this thing is broken, but it broke like 6 versions ago and I didn't even know it. So you need a version control system, and you don't want to have to be plugging into GitHub or some other source for it. You need actually, Alonso, can you click on the diff right above?
Yeah.
It's got a great little engine in here.
Yeah, might actually not be a great example for that. We might have to go to a different. I don't think they made that changes to this one.
Okay. But it'll highlight the differences that you made in your YAML code changes so that you know what was changed version to version and you're not relying on a change log or a human being calling out the changes that they made. This is how you not so much automate, but standardize the different versions. Because ultimately, I think there's a name for it. People call them like golden templates, something of that accord. But once you reach a template that works like 100%, you protect it at all costs because it takes a long time. It's an iterative process. It's the recipe building process. Once you got it, and you hold on to it. And then you don't let anyone change it. Like if we were to make a change in these templates right now, the guy who administers this environment would be writing me a nasty email tomorrow saying, why did you change this? Because some of these are the golden sets of templates. And all that to say, that type of structure is built into something like assembler. And let me make this point. Assembler is built on the back of an open source program known as Terraform. But Terraform is a command line interface tool. What we have done is, as an enterprise grade tool, is added this user interface, which makes it far easier and integrates many tools, such as the ability to have that version controlling system, but also to have the service broker system, because the service broker system does not exist on the command line side. Everybody's an admin or basically has access to the assembler side when you're using the command line. But we've introduced the service broker side, which allows you to gate who has permissions to what. So one thing, Alonso, or one place I want to go with eventually is to go back to the simpler environment, just so I can explain the implementation, but just let me know when you want to go there.
Yeah, absolutely. I think that was the biggest thing, was just showing version control. And actually, I noticed that when we were looking at the diff, it was just, again, I was checking against the same version. So number 3, there we go. Yeah, checking against the stuff. That's fine. But yeah, we have different versions. Yeah.
Small little thing. Someone added 2 apostrophes to make it work. That's code for you. Okay. So actually, before we leave this environment, can we go back and look at the deploy in the resource? So we saw Alonso deploy from the service broker side. That was us wearing our developer hat, or who's ever consuming these services hat. But right now we're in the assembler. This is more of the back end. This is the where service broker is the retail end. This is the back office now that we're in the assembler side. We can see the VMs being spun up. And yeah, if you click on that, we can also look at the provision. We might not have it at, there you go, history. Yeah, if you click on history there and click on provisioning diagram above it, find this kind of useful because I do a number of these deployments and it's interesting to kind of see what it's attempting to do. So, and this will kind of go towards some of the things I intend to talk about when I talk about how you actually set this thing up. Because when I was first learning about assembler, it's cool to see what it does, but it's like, what's the effort expended to make all of this work? It's not as complex as you might think, but as you can see here, notice it gets to a fork in the road there at the bottom, and it says profile VCF network, and then we have a red tile, 2 red tiles to the right of it. Basically, that's where the tagging system is constraining, and the tagging system was implemented in the YAML code that we looked at briefly. But the constraints come via the tag. So it says you can use this VCF network, you cannot use the VCF hard network. And so it's sort of showing you how the dominoes, as the dominoes fall, where they're allowed to fall and where they're not allowed to fall. So you can control a VM, whether it's deployed on this vSwitch or that switch, that D switch, this D switch or that D switch, this cluster, not that cluster, this data center, not that data center. All of that is controlled through the tagging system. And further, you can see Alonso at the top where it says machine allocation.
Mhm.
So it's showing the different stages and what each different VM that's being deployed, what it's doing. So you can look under the hood as this thing's being deployed. Again, if you're deploying 50, let's just exaggerate, 50 different VMs, although it's not, if you were creating a large stack that had 20 load balancers and 30 different, web applications, just so you could see at scale if your code works and have it actually working across all these different machines, it's not unheard of that you would have 50 different VMs. And if you did, you'd sort of want to know all the different provisioning steps. You don't want that abstracted away. But imagine trying to figure this out in a command line. It becomes very unwieldy to have so many different layers of abstraction to keep track of. You need a GUI to follow where things are breaking down, because inevitably, as you're working through a template, you'll find that certain stages, it's breaking at a certain stage. And GUIs really help to uncover that stage that it does break. So anything else you want to cover, Alonso, before I take us to the simple environment?
I think just one quick note there on the VCF and the placement logic. What I've seen often when it comes to defining tags and placement of where can something be placed is there's a really good discourse, a really good amount of dialogue around what does a given environment, what is the purpose of a given environment, right? When it comes to placing a virtual machine in a certain set of clusters or in one data center versus the next, this is a really good way of starting to get an idea of where should teams have access to resources and where should specific workloads live and sit. And one of the good ways of having flexibility to control that and identify where are my future workloads of this kind of project or of this kind of purpose going to be living and being maintained. You can control that through how things are tagged. And so, for instance, we could make the tagging be as general as it's this set of clusters, or it could be as specific as it's going to be on this specific cluster. Or we could do things such as, I don't care where this goes as long as it's a vSphere environment, because that's how my configuration works. It could be, I don't care which cloud it goes to. I want it could be native AWS or native vSphere. But the level of specificity can help you decide how flexible is this workload? And then from there, how do I define my deployment to place it properly in that location?
Mm-hmm.
Excellent. So Wes, would you want to show your environment first, or is there anything else
Yep.
we'd want to cover on this piece?
I think we're going to come back to this after
Okay.
it's deployed a little bit further.
Great.
What I sort of want to do is take us back. So Alonso jumped this into like kind of like further down the road. Everything's been implemented. He deployed some applications. I want to show you how we got to the point when we can start deploying applications on the service broker side or on the assembler side.
Excellent. So in the infrastructure tab?
Oh yeah, actually I'll take the mouse.
Okay, go for it.
Yep. So I'm going to change this into a different environment. We're changing over to a personal org where I have full administrative permissions, and also where I have access to the underlying vCenter. And that's where I want to start. So again, I'm on the assembler side up here. And if I scroll down, here's how you build this. If I just turned on assembler, the very first thing I would do is I come here under cloud accounts, and I would have to add a cloud account. And again, if AWS, GCP, Azure, or some others, vCenter. If I want to add my vCenter, I give it a name, give it the IP address, and throw in a cloud proxy. To get the cloud proxy set up, I just download my OVA, I deploy that in my vCenter, which then starts talking from my vCenter back to my assembler. And then once that's been established, I will come over here to cloud accounts and I will see my vCenter. And it's really that simple. Now, my vCenter over here, or actually, let me make sure I'm in the right vCenter. This is the right vCenter. This is what it looks like. And I'm showing it to you because I want you to notice the structure. I got data center A and data center B. I got cluster A1, cluster A2, cluster A3. I got cluster B1, cluster B2. Now, back in assembler, after I've established an integration with my vCenter, under resources here, it's going to start pulling in those resources. So it has under compute my cluster A1, 2, and 3, and B1 and B2. Under my networks, It has all my D switches, all my segments, because I'm also operating NSX-T inside of my vCenter environment. So I don't just have V switches and D switches, but I also have segments. And under storage, let's see, it's going to bring in, I got some vSAN running in there. I got some Kubernetes policies running in there to which are talking to my network attached storage. And so forth. So I just want you guys to understand that so far what we've done is connected the vCenter, and now assembler can see those resources and it can start to deploy them in using the instructions from the YAML code, the recipe, if you will. So now I'm going to scroll up from the resources section, and I'm not going to talk about configure just yet. I'm going to jump up to projects. So if I set up a project, and this is just a construct, this is nothing more than a folder. But notice how I've organized them. I got project data center A, project data center A2, project data center A and B, project data center B, B1 and B2. Obviously, you can see that I've structured this so that as an admin, and I start to work my way through what John versus Jerry, where they can deploy, I might say John can only have access to data center A, or maybe only data center A2 cluster, and Jerry can only have access to data center B and cluster 1. If I click into that card, I get a little bit of a wizard up here. It's going to show me some summary information, but I want to show you guys where it gets configured that I only have access to Cloud Zone Data Center B. So when I add in my zone, I could add in my data center A here, but I've only added in my data center B here. And there's a tag, Cloud Zone Data Center B. If I come down here to Cloud Zone, we can see where that was configured. So here under Cloud Zone, Data Center B, I got A and B. If I click on Compute, I can see that B has access to B1 and B2. I could have it just access to B1, but I have it access to both. But the point I want you to see here, because everything inside of setting up the administrative builds off of this concept, which is once the resources are in, you build projects, and the projects are then talking to your cloud zones. The projects are talking to your Kubernetes zones. Projects are talking to your flavor mappings, and let's just talk about that real quick. So flavor mapping, I can invent whatever I want to. I could put a extra large in here, but I have 3 basic sizes, small, medium, large. And as I create these different sizes, I say in data center A, a 6 vCPU and a 16 RAM constitutes a large. For data center B, I could have it be different, but I have the same exact value, 6 and 16. For image mappings, these image mappings are coming from my content library. So if I go back over to my vCenter and come here under content library, I got my data center A, and I got my templates, and I got my so these are my OVFs, and I also have my VM templates here. And these were created inside of vCenter. But again, now that vCenter is talking to my assembler, I can come back over to assembler, and those templates have been imported from vCenter. They're not really imported, they're just being referenced. So if I want to deploy any of these images that are stored over in vCenter, I can do it. And how I do it, I'm going to quickly jump out of this infrastructure, go over to design, and let's just do something from scratch. If I do a new from blank canvas and say test project, what project do I want? Let's just go with B. And I can say share only with this project or allow everybody to see it. Let's just say share only with this project. Okay, so I've created a blank canvas. And if I come under cloud agnostic and just drag in a machine, and then just drag in a network, and then tie this machine to this network, it's then populated some YAML code. So now this machine over here is referencing Cloud Network 1. This is Cloud Network 1 right there. But I haven't given it any constraints yet. So let's give it some constraints. Under the network, if I hit enter and say constraints, and it auto-populates, and then hit enter again and give it a tag, these are the different resources that are available for Project B to deploy. And you have to know your way around a little bit. I've gone ahead and tagged these in such a way that it makes perfect sense. But what I wouldn't want to select a D switch here, because that's not a network, that's just the switch. But if I didn't call it a D switch, I wouldn't know. In this case, I called it a cloud account. That's what I want. I want cloud account corporate corp.tanzu. And real quick, I'll show you where that is. If I come back over to infrastructure and click on Cloud Zone, Cloud Zone Data Center B, and click on the compute over here for summary, where here it is. This is where the tag was invented. So under my Cloud Zone, I gave it a tag of Cloud Zone Data Center B. If I go back up to the project level and click on Data Center B1 and click on what can be provisioned, same thing, Cloud Zone Data Center B can be provisioned. Going back over to the design tab, this is what I just provisioned, Cloud Zone. Cloud account, I should say. Now, having done that, for the VM, the image also has to be configured. So notice the images. These are the same images I just showed you that were coming out of the vCenter that are stored in the content library that I mapped into the image references. And now they're available to be just clicked and deployed. Flavor. This was that large, medium, small I just showed you. Let's pick a medium. And now let's hit test. And this is going to run through this simple syntax. It shouldn't have any errors unless I did something wrong. But it's just going to make sure that this thing should work. And then I can deploy it. Now I can deploy this from the service broker side, but I'm just going to deploy this from the assembler side to save us a few clicks. But this is the essence, successful, of making assembler push work to vCenter. And let's give it
Wes, just a quick note there, actually, if you want to show also on the constraint tag, just if we hit the X for a moment there.
Yeah.
If we wanted to just show back in that template, which I see is there in test, it's right there next to template.
Yep.
There we go. Yeah, if we wanted to show, for instance, the constraint tag here, if we just wanted to do some examples. So constraint, like if I wanted to constrain the placement of this particular virtual machine, we would just have the constraint tags for that as well, right? And then in there's some of those examples. So we see Cloud Zone Data Center B, cluster, and compute. So it just depends on the kind of resource, sometimes the placement logic as well.
Right.
Machine versus network. But yeah, that's essentially how you would associate those constraints for those resources too. Anyway, back to you, sorry.
Yeah, no problem. So yeah, we can see the test if we go over to resources deployments. Or yeah, we're already in it. So it's creating 4 out of 7. What I'm going to do is if I click on the vSphere, so I go back into vCenter, we can see that Ubuntu template. Let me actually drag this up so we can see it. This is what's going on inside my vCenter. These are the different tasks running, and it's being created. If I click on the inventory, let's see what we got going here. So we deploy this on B1 right here. And here it is. This cloud machine right here, the one that's turned off, that's the one that's just been created. And it has this nomenclature MCM 238. You could customize this. Let's actually just see where that is customized. But this is that machine right here. If you want to customize that, you just go into design. And this is the template I just created, the test. Or I'm sorry, I got to go into infrastructure tab. In the infrastructure tab, under the project, remember project data center B is the one I'm working within. This is where you can do the custom naming. And so it's, you know, a JSON syntax, but you could have it be whatever you want it to be.
Mm-hmm. Yeah,
so
a quick note on that as well,
yep.
On that section. So we see that the Cloud Machine 1-MCM and so on. So the default is essentially object name -MCM and then a bunch of numbers. So, and as a quick and dirty way of doing things, which maybe for Windows, it's not, it's just as a quick way to check. But if we wanted to go to that assembler location and see, for instance, if we wanted to change that so it's not Cloud Machine 1 but something else, we could just actually change that resource name right here. So we could type something else, and this would replace that in terms of the initial part of the naming. As far as global naming, if you have, say, project level or global naming requirements in that infrastructure tab, there's also a section that we've recently added instead called custom names. So here's where you can also adjust from that area that Wesley showed. We're starting to centralize on its own tab section here for custom naming. Both of them will work for now, but this is where we're moving to in terms of project by project or global naming for custom, if you want to do that.
So let's talk, and actually, if we go back to the vCenter real quick, here we go. So this is just a migration. So it did finish on deploying that Cloud Machine 1. I think this was, I don't know which one it was. I had two in there, but in any case, the basic that took all of 3 minutes. And again, assembler is not magical. It's just giving instructions to your vCenter. But you might imagine how it becomes a little bit magic when you have a series of different tasks being sequenced by assembler, because it can not just deploy the VM, but it can then have some further YAML code that deploys an application. And then once the application is deployed, it can further configure different parameters inside of the application. And then it can deploy another VM that's networked and starts talking to that application. And that's where I'll take us back to the more complex environment where we have some examples. And I'm going to go ahead and bring up our mother of all demos, Alonso, just to really take it to the next level here, so people can understand how the YAML code can get quite complex. But it's complex for all the right reasons. It's saving you a lot of time by being complex. Now, all right, so we're in the complex environment here, and I'm waiting for this design tab to load. Let's see if it'll get there. Okay, I'm going to go in through a different way. So I'm going to click on resource, and I'm going to find a deployment. This is one of the blueprints that's already been actioned. And I'm going to click on, actually, let me click on this one, the one I spun up this morning. All right, so we're looking at this one's currently hot. It's active. So when I click on Aria config here, it's giving me an IP address where this Aria config lives. And if you guys are with us in the past webinar, I think we use an Aria config instance that was created by assembler, but I'm going to go ahead and show you real quick how an application was deployed on top of a VM that was created by assembler. We'll see if it wants to work for us today. Here it is. And log in real quick. And we'll see, I'll show you this in the YAML code, how all of this kind of occurred. And just being a little bit slow. We got only 5 minutes left here, but we're going to get it all in. So notice I have 4 minions. Now, a quick recap, a minion is an agent. So in order for Aria config or sol stack config, which is the master node, in order for it to see its children nodes, an agent has to be installed on the children nodes, the children VM. They call it a minion. So 4 minions were installed. If I come back over here to the blueprint of the assembler, we can see the 4 nodes: Apache, Aria config. Aria config is both a master and a minion, MySQL, and an open card application. And if I click on this open card application, I have an IP address for this, which is just a simple web application. Actually, it might not be HTTPS, it might just be HTTP. Here we are. So this is the application that was created, and it's currently running over here, open cart. This is the address for it. And again, we looked at the Aria config and the IP address that's for it, and we have some SSH commands we could run to get into the MySQL and the Apache instance. They're all running on this particular network and this CIDR pool. All that to say that how was this created? So if I click on the template up here, it'll take me into the design phase where I can see the YAML code. The YAML code basically flows from top to bottom. The compiler reads it top to bottom. So we can see here that certain usernames were created. We can see passwords were created. This is all kind of configuration. So it's not just creating the VM, but it's also creating and configuring the application running on top of the VM. So if I click on Aria config here, and this isn't like code, this is declarative programming. So it's kind of easy to read. It's different to write it, but to read it, we should be able to kind of figure it out. Various key values here, but let's just scroll down. This was all kind of the deployment of the VM stuff. But when we get into the green stuff, this is the configuration. This is stuff that's happening at the command line interface after the VM is deployed. And we can see some username, password stuff was set up. We can see a variety of different files, like licensing was configured, a license was input. That license came from over here under the infrastructure tab. We have a secrets manager. Where is it? Oh, we don't have administrator privileges in this environment, so we can't see it, but secrets manager would be in here. which is just a place where you can store some passwords and then use it as a variable in your YAML code so that it's not exposed. Um,
Yeah, and
for
as a quick
yeah,
note also on this is so we're seeing as here many different ways that we can actually go about configuring the operating system here. That what Wesley's showing in green there, that is through Cloud Init, which can be or Cloud Config, shall we say, which can be either Cloud Base Init on the Windows side or Cloud Init on the Linux side. And this is a almost like a run once during configuration approach. Well, these things can also, depending on the kinds of things you need to do on a virtual machine, be done with your cloud management platform, right? Like our cloud or configuration management platforms, like such as Salt or Ansible or PowerShell scripts and so on. Depending on what you have existing, right, and the kind of centralized tooling you need, this is another approach for more of the run once to configure activity.
right. But where config or any day two operation comes in is assembler can only do this on day zero. So if this were to change, if after this is deployed, I wanted to change the configuration here, it wouldn't work. It only works as an initial deployment. I would have to use an Ansible or an Aria config in order to go in and alter at the command line. And that's where those tools kind of fit into this whole life cycle. But just to sort of so that people can understand how you get to the point of where in order to sequence a number of applications talking to each other, you're gonna have to do config on top. In other words, you got to spin up the VM, put the OS on the VM, and then put the application on top of the OS, and then configure the application before you can move to the next step of networking different devices, different machines, different applications together. So it's necessary if you want to use this at scale, it's necessary to have to sort of sequence many different parts of the application right here on day zero. We have 2 minutes left. Alonso, do you want to put a bow tie on this?
Yeah, I think from you essentially put a good loop or circle around what we've been talking about. But essentially, as Wesley mentioned, any kind of service creation or service maintenance full scale is going to require the administration and the management of not just the application level and the operating system level, or not just the infrastructure virtual infrastructure level, but both. And having a good way to centralize that kind of activity, as well as standardize it, because one of the things that we see often is that there isn't necessarily a standardized process for many of our customers where these things are written down. Somebody knows how to do them. Maybe a couple people know how to do them, and then there's handoffs and continuous pointing and clicking, and a following of steps. But that is error prone. That is variability prone. There is a lot going on that if it were written down and centralized, then that process can be repeatable and iterable, so you can make changes to it more quickly. That's ultimately the end goal of all of this, and combining our things together of operating system management, package management with infrastructure and deployment managing as well. That's where these things come together, and we see that as a full scale, full circle example when we do a service deployment, such as what we're seeing here. One of the things that I would leave as a takeaway as well is in your existing processes, whether it's a very complicated deployment or a very complicated task or something that is done very, very often, how time consuming, how many employees, how much manual process, how much potential human error is there in your existing deployment of services? What these platforms start to enable you to do is take process and make it more enterprise grade, more streamlined, and easier to change. That would be, I would say, the big message behind these different steps.
Yep. And I'll put one last bullet point in here. Again, I try to make it clear, I'm going to try to make it clear again that assembler is both used in the development phase for your developers, but also in the provisioning. For instance, if you find yourself having deployments failing often, even if it's just once a week, even if it's just once a month, and you want the ability to recreate the entire deployment of 20 virtual machines talking to each other in a distributed architecture, and this could also be Kubernetes based. It doesn't have to be just traditional VM structure. But if you want to redeploy that, it's not necessarily a developer workflow. It's just a production workflow, an IT operator workflow. So it can be used both in development and both in IT operator. And then, of course, config comes in behind that as a day two operation to do drift remediation thereafter. But that wraps it all up, and we thank you guys for attending, and yeah, we'll send out the link.
Thank you all.
Thank you.